Here we are, example number 3, function composition and inverses. This will be assignment 21 again. An application of this. All right, so here's the deal. We have one function that takes a Celsius temperature, x, and changes it to a Fahrenheit. You put the Celsius in there, you crunch the numbers, and it'll change it to a Fahrenheit. For example, if the Celsius temperature was 20 degrees, you would put 20 in for x, do the math, and it comes out to be 68, all right? Now look, the example with the numbers is not in the problem. This is just to get you to thinking about why this process we're about to enjoy is of benefit to people. So, if the temperature was 20 Celsius out, you'd have to put that in there and crunch it and change it to a Fahrenheit, all right? The other function would then take that Fahrenheit, plug it in for x, crunch numbers, and it would give you the corresponding Kelvin temperature, which is a temperature that scientists use. So the point is, if you took that 68 we just calculated and put it in for x here and do those numbers, and again, if we were together, we'd spend more time doing this, but that comes out to be approximately 293.15. All right, so here's the point. Mathematicians are looking for faster ways to do things. If a person wanted to go from Celsius to Kelvin, the way we have it right now, they'd have to first change that Celsius to a Fahrenheit with this formula, and then take that Fahrenheit and change it to the Kelvin with that formula. And it would be 2 calculations, 2 conversions. Would there be a mathematical formula that would take us straight from Celsius to Kelvin without having to do Fahrenheit in the middle? All right, is there a faster way to do this? Yes, and the answer to that is composition. So, when you have 2 functions and you're going to do composition, I would suggest to you there's 2 possibilities. It might be that we're going to do f of k. It might be that we're going to do k of f. And now, this is where the critical thinking comes into play as to which one is it for this question. And I'm going to share with you what's worked for the vast majority of people who've come before you. My marker is kind of dead, that's why I'm shaking it here. All right, here's what I do. What would be the function that would change Celsius to Kelvin? We want to end up with a Kelvin temperature, don't we? All right, and if we want to end up with a Kelvin temperature, it says, take a Celsius, change it to a Kelvin. What do you want to end up with? Kelvin. So I look at this and I think, all right, if I want Kelvin to be the final calculation in math, how do you make sure that a particular thing is performed last, right? Kelvin is the last calculation we want. It's what we want to land on. In math, if you want something to be the end result, Kelvin, don't you put that outside the parentheses. It's this one. We want to end up with a Kelvin temperature, and we want Kelvin then to be the final operation. And in math, you're going to be the final operation if you're outside the parentheses. So that's my best attempt at that. I hope that made sense to you. If not, I hate to say it, flip a coin. No, I hope not. Look at the question, ask yourself, what do I want to end up with? Kelvin temperature, and whatever function calculates Kelvin temperature, put it on the outside. We'll practice this on another one with example number 4, if that did not make complete sense. But we want to end up with Kelvin. Put Kelvin on the outside. That's in keeping with the order of operations. So, here's the idea. Just like the 2 examples we did earlier, therefore, we will do the function inside the parentheses first. And so f of x would be this expression over here. So this is the mechanical stuff that we were talking about earlier. Okay, so now it's k of expression. And now we'll come over to k and put expression in for x, right? This expression under my hand is going to take the place of x, isn't it? So x becomes expression. All right, so here we go. Equals 5/9 times expression. I can hear you guys. Awesome. You're saying it so loud, I can hear you. Plus this. Okay, now let's go ahead and clean this one up for illustration. okay? So anyway, if we go ahead and distribute this into the parentheses, the cool thing here is that the 5/9 times the 9/5, that's 45 over 45, it's 1. That's 1x, right? The 9's cancel, the 5's cancel, cool. Plus, all right, let's see, 5 divided by 9 equals times 32. So that gives us this 17.7 repeating, plus 255.3722. And then finally, let's put this up over here, x plus, let's add those numbers together. So that 17.7 that's in the calculator plus 255.3722 comes out to be approximately 273.15. All right, now, here's the chain of things here. This took a Celsius, changed it to a Fahrenheit, and then took that and changed it to a Kelvin. So the point is this new formula here should hopefully change a Celsius directly to a Kelvin without having to do Fahrenheit. So let's check the numbers and see if this worked. Earlier we did Celsius, Fahrenheit, Fahrenheit, Kelvin. What happens if you put 20 in there? 20 plus that number, 293.15! It did it directly. See? So it cut out a step. And that would be the formula, the mathematical expression that would take a person directly from a Celsius with a Kelvin without having to do a Fahrenheit in the middle. And that's the whole point of it. It's faster. I wanted to share with you, I was driving through Scranton, Kansas, and I was looking at the bank sign there. And it's one of the most cool signs I've ever seen. Most bank signs will give you the Celsius and the Fahrenheit. But as you're about to see, maybe, I don't know if you'll be able to see it very well, but this particular sign in Scranton, Kansas is pretty cool. Because it shows you the Celsius is 20 and the Fahrenheit is 68. But it also shows Kelvin, 293.15. So Celsius 20, Fahrenheit 68. Kelvin, 293.15. Celsius 20, 68 Fahrenheit. Kelvin, 293.15. And they even made the sign expand a little bit to make the Kelvin fit. So I think that's pretty cool of them in Scranton. They must really love their science in Scranton, Kansas. I got to share with you that when I stopped to take that video, pulled off to the side, took some video, I was getting ready to pull away, and woo! Siren behind me. And I thought, what? What? I'm wearing my seatbelt, I drive slow, I used my turn signal to pull off, I wasn't quite sure what was going on. So the gentleman walked up, he was very cool, and he said, hey, you want to tell me why you were taking some video of that bank? And kind of hard to explain, isn't it? Well, you know, I'm a math teacher and Celsius, Fahrenheit, Kelvin. And anyway, eventually he's like, okay, I guess so. Still kind of seemed a little quizzical about it, but you know, he was cool, everything was fine. But anyway, just thought I'd share that little anecdote with you. We will now do another example of composition. Cool.